calculators are base 10. This is what our calculators are in. Some of the newer calculators, you can change the base value, but it doesn't hurt to remember where this is coming from. And then E is always used for natural log. And then this would be your common log. So change a base formula for any logarithmic base a and b and any positive number m. Then I can write log base b of m to be log base a of m, this should be capital M, over log base a of b. This is just changing the base. And so we're going to use 10 or e, depending on if we're doing common logs or natural logs. Usually it doesn't matter what base you change it into, it will give you the same answer. So this one here, find the logarithm using common logarithms and the change of base formula. So on this one here, the old base goes on the bottom. So this would be log base 10, we don't have to write it, of 20 over log of 3. Okay, the next one, again, the smaller base goes in the denominator, log of 100 over log of pi. And then this one, log of 25 over log of 4. Sometimes you'll get numbers that you can actually use and get answers. Other times it doesn't happen. But if we throw these in the calculator, this one here will give us 2.72683. And remember, you only need 4 decimal places. This one thrown in the calculator gives us 4.02293. And the last one gives us 2.32192. None of them needed to be rounded up 4 decimal places unless they tell you otherwise, always. So I don't want people going, how did you get this calculator? On the calculators, make sure it's going to start a parentheses. Make sure you close those parentheses. It'll start it at 100. Close the parentheses after that 100. The 25, close the parentheses before you divide. Otherwise, so I'm going to write on here, be careful. If putting in this in the calculator, so let's grab this one here. If I did log, it's going to be log, and it's going to start the parentheses for you, 100. If you don't close the parentheses and just hit divide, and maybe you remember now, your calculator does, PIM does, it's going to do everything in the parentheses first, and then it will do the log of that value, and that is not the same. Log of 100 divided by log of pi is not the same as the log of 100 divided by log of pi. So be very, very careful. Make sure you close that parentheses there. Better yet, use your fraction bar and you won't have to deal with it. Okay, simplify this one. There is a long way and a short way on this one. So on this one was changed to base 5. So for us to calculate it up, there's 2 ways. We can do a change of base on both of them. So I'm going to do the long way and the short way. So this would be log base 8 over log of 5 all over log of 2 over log of 5. Now what I've done is I've changed everything to base 10. But we now have a complex fraction. So with our complex fraction, we multiply by the reciprocal of the denominator. Log base 5 over log of 2, log of 5 over log of 2. And you can see that these are going to cancel out. These are going to cancel out, and you're left with log of 8 over log of 2. Now you can reverse your base, your change of base. Could we've done it here? Yeah, I guess we could have, but we're used to having base 10. So this would have been the shortcut, was to go straight to here and ignore the base 5 and change your bases. Since the bases are the same, just change them to 10. And then this would then log base 2 of 8, whatever, the small base with the denominator. And so really this is asking us 2 to what power will give me 8. And hopefully you know that it's 2 to the third power. 2 to the third power equals 8, so x would have to be 3. I don't know if this one said, yeah, it didn't say. It just asked you to simplify it. So getting it to log base 8 over log of 2, I'm sorry, log of 8 over log of 2, or even getting to this one would have been simplified. But anytime they tell you to simplify, if you can get it to a number, do take it down to a number. Okay, so let's look in kind of like word problems then. Students in an accounting class took a final exam and then took equivalent forms of the exam at monthly intervals thereafter. The average score S of t as a percent after 7 months was found to be given by the following function. And they go, what was the average score when the students initially took the test? Well, that's time equals 0. You put a 0 here, you're going to have log of 1, but log of 1 equals 0. And the 15 times 0, 0, 0. So it's left with just 78. You didn't even have to use a calculator or anything for that. You plug it in. Now, do keep in mind t is in months. So the next one, what was the average score after 4 months? So S of 4 equals 78 minus 15 log of 4. So that was plus 1, yeah, plus 1. Or log of 5. And we put this lovingly into the calculator. And we get 67.5%. Okay, then it says graph the function. You're going to graph the function on the calculator. If you're going to do this, you would use a window 0 to, I don't know how many months you would want to go. Excuse me. Maybe to start 12 months, you might want to go, say 5 years or whatever. So 5 years would be 60 months. So we can always go 0 to 60 on our x values. And then our score is starting at 78, but we know it's going down. So maybe do you can't get less than 0 on a test, right? So 0 to 80, since we know the beginning score is 78. That will give us a nice window of what's going on. Okay, and this is after what time was the average score 50? Well, this is one where we would have to play with a little bit. Actually, now that you guys know logarithms, we can actually use logarithms. So we have S of t equaling 78 minus 15 log of t plus 1. And we want to solve for t this time. So it's going to be 50 equals 78 minus 15 log of t plus 1. Subtract 78, subtract 78, and we get a negative 28 equals negative 15 log of t plus 1. Now this is no different than before when you have done things algebraically. I'm trying to get the t by itself. Divide by negative 15, divide by negative 15. and we get 28 over 15 equals log of t plus 1. Okay, so log of t plus 1 equals 28 over 15. This is a base 10, so 10 to the 28 over 15 power equals t plus 1. So you put this into the calculator. And you get 73.56 blah 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 equals t plus 1, subtract 1, subtract 1, and you get 72.56 equals t. So this is about 72 and a half years. 72 and a half years, sorry, months. I was thinking years. A years, it's about 6.5 years. Okay. So we would expect that this is going to drop fast at the beginning, but if they're out there doing this, they're not going to forget the material. So this is your way of working backwards if you're trying to find when does the score happen. It took about 72 and a half months, so I can't even claim the years. It just took a little bit more than 6 years. Okay, and this is the end of the second video. Yes, the yesterday's video, 1 through 67, every other odd. I'm adding 10 more problems on there, so really about 3 more problems. Okay, go back.